Good day, students. Before now, under special course, we have considered ellipse. This time around, we be talking about parabola. And then, what do you mean by parabola? That's the locus of a point, which moves such that its distance from a fixed point called focus and a fixed straight line called directrix are always equal. Now, I'm going to show that. Now, I want to pick a point. If you look at this drawing here now, let's say I'm removing this drawing. Let me just say I have a blank space. I pick a point outside. Now on this point here, where I have this point can be rotated or can be moved from this point where it is now to another point, and it's going to form a kind of path, just like some of those things we said under ellipse. Now, see the curve, the special curve we're considering is called parabola. Now, what we're trying to say is that when you pick a point on this parabola, I'm picking this point from this drawing, I'm picking this point. What we're trying to say is that if you draw from this vertical line, we call this vertical line directrix, and then we have this horizontal line we call the axis. If you draw from the vertical line any point on wherever you have the perpendicular distance from this directrix to this point, the distance from that point to the point on the parabola, you can take note of that. Then on the horizontal line, which we call the axis, if you draw a perpendicular height or line from the axis to meet the point on the parabola, the distance will also be equal to distance from this one. Now, what we're trying to say is that this point here, if I draw a line at 90 degrees to touch the directrix, that distance will equal the distance that I will take from this point to touch the axis. What am I trying to say? If from this point perpendicularly to the directrix is 50, then from this point to the axis perpendicularly will also be 50. What we're trying to say is that from P to X will also be the same thing as P to F. From P, this point, I call it P point, to any part here, in as though it is drawn at right angle, will also mean the same, will also be equal to the distance from this point to any part on the axis, provided the distance is taken perpendicularly. Now, the highest point on the parabola is taken as the vertex. This is the highest point. I can turn it this way, and then we say this is the highest point. We call it vertex, that's V. Now, this is the fixed point, focus, I call it F. This vertical line is the directrix, and this horizontal line is the axis. What we're trying to say is that the ratio of what? This distance from here to this end to distance from here to this point equals to 1. And that's the case with parabola. And that is what we call the eccentricity. So we always say that the eccentricity of a parabola is equal to 1. Don't forget that the eccentricity of the one we considered before now, which is ellipse, is half. It's not up to 1. So it implies that the distance from the focus to that point divided by distance, a perpendicular distance from the direction to that point equals to 1, and that is the eccentricity we are talking about. We either say it is 1 or unity. After now, we're going to pick an example, and it's not going to be on the board. I'm going to draw on the table. That's the example we're going to start with that first example to discuss parabola.